Good day. I am Levon D. Contemplate. So our problem is solve probs 7.7 and 7.11 using Morse circles. So since problem 7.7 is in line with 7.5 to 7.8, so the problem for 7.7 is for the given state of stress, determine the principal planes and the principal stresses. And for the 7.11, since it is in line with 7.8 to 7.12, so the problem for 7.11 is, for the given state of stress, determine the orientation of the planes of maximum in-plane shearing stress and the maximum in-plane shearing stress, and last is the corresponding normal stress. So, let's start. We have given points 40 MPa, 35 MPa, 60 MPa. As you question about the negative in the given points, you just have to look for the arrows. Example, here in 40 MPa, this arrow is going to the left side, so it is negative. And in the 60 MPa, the arrow is still going to the left side, so negative also. In this side, in X, you just have to find the given points. So Gx is negative 60 and negative Txy is negative 35. So as you question about again in this Txy 35, it is negative because the arrow here is going to left 35. So it is negative. So next is y. So the points of gy is negative 40 and 35, positive 35 because the arrow here is going to the right. So it is positive. Next is C. To get the C, you need to use this formula. Gx plus Gy over 2. So the answer is negative 50 MPa. So here. It is the center in this circle. So as we plot it in the circle, it will look like this. This is negative 60 MPa, negative 40 MPa, positive 35 MPa, and negative 35 MPa. And this is the center. Next is tan B is equals to Gx over Cg. So to get that, you need to look for the points G to X. So it is 35. Then points C to G, it is 10. So it is equals to 3.500. Next is B. To get the B, you need to times it. Tan minus 1 times 3.5. So the answer will be 74.5 degree. Next is theta B is equals to minus 1 half B. It is 1 half because we know that this side is negative. I mean, it is negative because we know that this side is negative. So the answer will be negative 37.0. Next is A. 180 degrees minus B is equals to 105.95 degree. It is the half of this. Next is theta A. 1 half minus A is equals to 53.0 degree. It is positive because we know that this is positive here. So we have the answer of A in 7.7. The principal planes. Next is R.
Square root of CG squared plus GX squared is equals to square root of 10 squared plus 35 squared is equals to 36.4 MPa. Then next is G minimum. So G average minus R is equals to negative 50 minus 36.4 is equals to negative 86.44 MPa. Then the G maximum is equals to G average plus R is equals to negative 50 plus 36.4 is equals to 13.6 MPa. So we have the answer for B in 7.7. The principal stresses. Next is theta D is equals to theta B plus 45 degree, the half of 90 degrees is equals to 8.0. Then theta E is equals to theta A plus 45 degree is equals to 98.0. So we have the answer for our 7.11, the orientation of the planes of maximum in-plane shearing stress. Next is TAV. So TAV is the R only. So it is 36.4 MPa. So that is the answer for our letter B, the maximum in-plane shearing stress. Then last is the G prime. So it is the G average, negative 50 MPa. So it is the answer of the corresponding normal stress. That's all.